Hello everyone, I Anju Joshi, working as an assistant professor in the Department of Computer Science and Engineering from ABES Engineering College, is going to deliver a lecture on functional dependency. Today, I'm going to discuss some concept regarding what is a functional dependency, what are the types of functional dependency, how to determine whether a given functional dependency is valid or not, and we are going to solve some practice problem based on the FD of functional dependency. So before jumping into the formal definition of functional dependency, let's just discuss the basic concept of FD or functional dependency. So let us assume that there is a table and it consists of two columns, which are basically the set of attributes alpha and beta, and there is a functional dependency from alpha to beta. So a lot of people have a misconception that functional dependency is equivalent to a mathematical function. They think that it is like a mathematical function like from alpha to beta, where we can put the value of alpha and we will compute the value of beta. No, it's not like that. Function dependency basically means that if I tell you the value of alpha, then we can search the value of beta. So how can we search the value of beta? Let us think that now let us consider that this table again, and we have two attributes alpha and beta, and this alpha have values like A, B, C, and D, and correspondingly beta also has values like 1, 2, 3, 4. And if I tell you that the value of alpha is A, and if I ask the question that when the value of alpha is A, can you tell me the value of beta? So yes, clearly from this table, we can see that when the value of alpha is A, we can see that the value of beta. So this is basically the functional dependence. However, in this scenario, we can see that all the values of alpha are different. Let's consider the second case like this. This is again a table, and we are again having two attributes alpha and beta, and these are the values of alpha like A, B, C, and D, and correspondingly we are having the values of beta as 1, 2, 3, and 4. And if I ask you again the same question, that if the value of alpha is A, can you tell me what is the value of beta? Clearly from this table we can see that the value of alpha as A is repeated. The value of alpha as A is repeated multiple times. So for this row or tuple, if we see that the value of A is alpha is A, the value of correspondingly the value of beta is 1. But if we see this row, then the value of when the value of alpha is A, the value of beta gets changed, it is 2. So here in this scenario, we cannot determine the value of beta on the basis of alpha when the values of alpha get repeated. So again, as I was considering that in mathematical function, if I say that this is a mathematical function from alpha to beta, and when we put the value of alpha, we can compute the value of beta. So if I put the value of alpha as 1, let's suppose if I put the value of alpha as 1 and I compute the value of beta as A. Okay, if we consider that this statement is short true, and if I give you two other statements, when I put the value of alpha as 1, I get the value of beta as B, and if I put the value of alpha as 2, I get the value of beta as. And if I ask you the same question, that in these two statements, which of the statement do you think is short false? So we can see that if this statement is true, that if we put the value of alpha as 1, we get the value of beta. But if we put the value of alpha as 1, we can never get the value of beta as B. So this statement is false. However, this statement can be true. So from this we implies, okay. So by this statement we can imply, it can be implied that for the same value of alpha, we cannot have two different values beta. Okay, so this logic of mathematical function is applied on, the same logic is applied on FD or function dependency on DBMS. So we can now conclude that let's take to scenario again. This is a table with two attributes, alpha and beta. And this is again two table with alpha and beta. We have some same values as AACD for alpha, and for beta we have values 1, 2, 3, and similarly here we have tuples like A, B, C, D, and respectively we have the values of beta as 1, 1, 3, and 4. So we can now conclude that for same values of alpha, we cannot have two different values of beta. So this is clearly not a functional dependency. However, this scenario can be true for case 1 or scenario 1 employing to this table, and case 2 for two different values of alpha. We can have same values of. Now this is permissible, this is allowed, but this is clearly not allowed when we talk about the functional dependency from alpha to beta. Okay, so this is the whole basic concept of FD. Now let's go back to the actual or the formal definition of FD, which says that, let us consider, so let us consider that we have a table for a relation R, capital R, and we have two set of attributes, A or B, or we can say alpha or beta, and both A and B are subset of R. That means they both consist from R, and if there is a functional dependency, from alpha to beta, and let us assume that we have two tuples T1 and T2 which have the following values. So clearly the functional dependency definition says that if T1 of alpha is equal to T2 of alpha, here we can see that T1 of alpha and T2 of alpha both have the same value as A. Then it implies that T1 of beta will always, or it should always be equal to T2 of beta. That means it should always have the same value. Then only it will be called as functional dependency. However, we can also say that we have this table. The second statement say that we can also say that for two different values of alpha, we can have the same values of beta. That will not be an issue. So if this is a case where we have a relation R and we have two attributes alpha and beta, and let's suppose that the value of T1 tuple is A and T2 tuple T1 of alpha is A and T2 of alpha is B, then we can have the values of beta. And if the values of beta is 1 and 1, so that's not an issue. So for the two different values of alpha, we can have the same value of beta. But if the values of alpha, that means the values of T1 and T2 tuple is the same, then the value of T1 of beta should always be equivalent to T2 of beta. So this is the formal definition of functional dependency. Now let's check. Okay, so as I've already discussed the definition of functional dependency. So functional dependencies are of two types. First type is called as trivial and the other is called as non-trivial. Trivial function dependency says that if there is a function dependency from alpha to beta, and if beta is a subset of alpha, then this kind of FD, the function dependency, will be called as trivial function dependency. Okay. Like for example, there is a function dependency from AB to A, you can clearly see that this is the subset of alpha. So this kind of function dependency is called as trivial function dependency. Non-trivial function dependency means that if there is a function dependency from alpha to beta, and if beta is not a subset of alpha, then this kind of FD will be called as non-trivial. For example, if we have a function dependency like AB, if we have a function dependency like from AB to ABC, you can clearly see that this is not the subset of alpha. So here we are getting some new value, some new attribute like C. Okay, so these are the two types of function dependency. Now we'll discuss some problem. We'll discuss some problem based on this function dependency. Okay, so this is a question, and these are the questions are repeatedly asked on many competitive exams. And the first question says that we have given this table, given the following table and dependency, we have to find out which of the function dependencies are valid. That means which of the function dependencies are true or correct and which are not. I've already explained that for a functional dependency, let me explain it once again. That if there is a function dependency, if there is a table which consists of two attributes alpha and beta, and if there is a function dependency from alpha to beta, then clearly then T1 of alpha is equivalent to T2 of alpha, then it implies that T of T2, T1 of beta should be equivalent to of beta. That means for the same values of alpha, we cannot have the different values of beta. If we have the value of alpha as A and A repeated two times, then the value of beta should be same for both the terms. Here we have 1 and 1. So if this condition get passed, then only it will be called as a function dependency. Then this function dependency will be valid, otherwise no. So let's check it one by one. Now the first option says that there is a functional dependency from A to B. Now let's take this table. Here on A, we are getting the value of BC as 2, 3. That's not an issue. When we have the value of A as 2, we are getting the value of BC as A and 3. That is also correct. Now on A again, now we can see that A got repeated. Now for the value of A, we are getting the value of BC as 2 and 3, which is okay. We are getting the same value. That's not an issue. Now again, A got again repeated. It got repeated 3 times. And in this case, when the value of A is small a, we are getting the value of BC as 2 and 3, which is the same in all of the 3 cases. So this function dependency holds good. Okay. So this functional dependency is valid, good, because it is satisfying the constraint of functional dependency. Now let's check for the option 2, which says that from DE we can functionally determine attribute C. Now we'll check the value of B and C one by one. Now on the value of 4 and 5, we are getting the value of 3, which is okay. Now again, this 4 and 5 got repeated, and for 4 and 5, we are again getting the same value of C, that is 3, which is correct, which is okay. Now we can see that on 6 and 5, we are getting the value of C as 3. Okay, we can have that. For different values of alpha, we can have the same value of beta. That is not an issue, as I've already discussed. Now in the fourth row or fourth tuple, we can see that for the value of DE as 6 and 6, we are getting the value of 3. That is also correct. So this functional dependency also holds true, and it is also valid. Now let's check for the option C. This says that from C we can functionally determine D. Now we'll check the value of C and DE one by one. Now on the value of 3, we are getting the value of DE as 4 and 5, which is okay, allowed. Now on the value of 3, again we are getting the same value of DE, which is correct, which is okay, which is allowed in FD. As we have seen, as we have already discussed, that on the same value of alpha, we should always get the same value of beta. Now here in third tuple, we can see in third row, we can see that on the value of 3, when the value of C is 3, we are getting the value of DE as 6 and 5. Now this row violates the rule. So this is not allowed in FD. Now we don't have to check it further. We can clearly say that this function dependency is not valid. Option C is not valid. Now let's check for the option D, which says that from BC we can functionally determine A. Okay. So one by one we'll check the value of BC and A together. So when we have the value of BC as 2 and 3, we are getting the value of A as small a, which is okay. Now for the value of A and 3, we are getting the value of 2, which is okay. We can have for the different values of, alpha. Now we can, again, we'll see in tuple 3, when we have the value now, we can see that on BC, the value of 2 and 3 get repeated. So on 2 and 3, we are again getting the same value of, we are again getting the same value, that is small a for capital A for this attribute. So this is allowed. This is what the functional dependency is all about, right? Now we'll check for tuple 4, which says that on 2 and 3, again we are getting the same value. So 2 and 3 is getting repeated 3 times, and whenever we can see that whenever we are checking that the values of A remains the same. So this functional dependency is also. So this is how we can determine whether a given functional dependency is valid or not. Now let's take the other question. Okay. So this question also says that the following functional dependencies and the table is given to us, and we have to find out which of the functional dependencies are valid or not. So in order to solve this question faster, we can use some short trick. Okay, these are the short trick. Before explaining this short trick, let's get back to the question. Okay. So here the first option is, it says that from from A we can functionally determine B. And the next option says that from A we can functionally determine C and D. And from C we can functionally, the C option says that from A we can functionally determine B, C, D, E. And from D option says that from A we can functionally determine C. So these are the four options. Let's take the first option. Okay. From A we can functionally determine B and C. Now before solving this question, let's get back into the table and see that in the table we can see that for A we have different values of A. We have different values of the tuple like A, B, C, D. So if this scenario comes, you can easily solve the question very quickly. See, the first short trick says that we have to check the value of A. If all the values of A are different, then all the FDs, all the functional dependency will hold good or will be true irrespective of the values of B. Are you getting the point? So the shortcut says that if there is a functional dependency from alpha to beta, we will check all the values of alpha. If all the values of alpha are unique, we need not to check the values of beta. Okay, if all the values of alpha is unique, all the functional dependencies will be valid or will hold true irrespective of the values of beta. Okay, because the only constraint in the functional dependency is that for the same values of alpha, we should or we cannot have different values of beta. Or we can say that for the same values of alpha, we should always have the same value of beta as well. So if the values of alpha is unique, or if the values of alpha are unique, it does not depend on the beta. We need not to check the values of beta. We can clearly see, or we can clearly say that if all the FDs or all the fractional dependencies that are given in the tables are valid. So let's get back to this question. As we can see that all the values of A are unique or different, we need not to check the values of beta. Okay, so all these functional dependency will always be valid or valid. This is a faster way of solving a question. Okay, so all these options will be valid functional dependency. Now we'll see the next option, that is E in F. It says that from BD we can functionally determine C, and from BDE we can functionally determine C. Okay, so if the first shortcut trick doesn't work, we will move on to the step two, which says that we will check the value of beta or B. If all the values of beta are same, then we need not to check the values of alpha. Irrespective of all the values of alpha, the functional dependency will always hold good when all the FDs will be valid. You can understand from this question. See, here in this question, here in this scenario, we can see that all the values of beta, here beta is C, absolute C, here all the values of C are C. So we need not to check the value of alpha. Okay, here we need not to check the value of alpha. We can directly say is that all the FDs are valid. Now the functional dependency or this beta does not depend on the value of alpha. We need not to check the value of alpha if all the values of beta are same. So these are the two short tricks that we can use to solve the question easily and quickly. So I hope you people could get the basic idea of what the functional dependency is all about. Today we discussed about the functional dependency. What are the types of functional dependency? How can we determine whether a functional dependency is valid or not? And we also solved a practice problem based on this concept. In the upcoming video lecture, I'm going to discuss some furthermore topics on DBMS. That's all from my side. Thank you.